know that circle is a shape or a plane shape or a diagram that is of this form, and in any well-drawn circle there is going to be what? A fixed point here called the center of the circle. Now, from this center of the circle, any line drawn from this center to touch any part of the circle. So I have to say this: part of the circle is what usually referred to as the circumference of the circle. So any line drawn in such a way that it moves, its starting point has to be from the center and landed and stops on the circumference of the circle. Such a line is what we call the radius of a circle. One other important thing that is of interest to us as far as circle is concerned is what we call the diameter. Diameter simply means a line or a straight line that touches a circle in two parts with one condition. Such a line will have to pass through the center of the circle. So diameter simply means a line that looks like this. So we can see that the line touches this very circle we have here in this at this point as well as this point. So we can see that diameter is a line that will touch circle in two parts, with the condition that such a line must pass through the center. So the fact that I have this one here and this is a line, we can see that this line touches this circle at 2 points. Doesn't qualify these lines I have here to be referred to as the diameter. For any line to be called diameter of a circle, such a line must what? The first condition is that the line must touch the circle in two parts and the line has to pass through the center. So it means both this line and this line must be a single line that runs through the center of the circle in such a way that what? It touches the circumference in two parts. So that is what we mean by what? The concept of what? Of diameter. Now one other thing that is of interest to us is the concept of chord. Now when the circle is drawn like this, chord is of two types. There is a particular chord that, now chord in short simply means a line that also what? Touches the circle in two parts. It is just like radius. But the only difference between chord and the radius is that it doesn't necessarily pass through the center. So it's usually a way of dividing circle into smaller. Now that is a line that is going to divide circle into two parts. But in its own case, one line will be bigger than the other. So good example of what we call chord is the line that runs or that moves in this pattern or in this form. I hope that is clear.
Yes.
Now, the diameter that I did mention of above here is also a chord. It's a special case of chord whereby it divides the circle into two equal parts. And when this situation of chord happens, so what we are going to observe is that the circle will be divided into two parts. So we can see the smaller part as well as the bigger part. This smaller part of the circle is what we call the minor segment. So the division will now change a circle to what we call what? A segment. While the bigger one we have here is called the major segment. So let's say this is the brief introduction to what we want to talk about in circle. So from this one now, we can move ahead to the first theorem that is of interest to us. So you can recall, the essence of this class which we are doing here is to ensure that passing of WAEC, the mathematics WAEC is very easy for our students, that is the one that are passing out, or for any number of words of mathematics. So everything we are doing here is just toward what? That's WAEC syllabus. Now we want to start talking about the theorem. Now the first of the theorem is the one which states that what? Angle at the center is twice the angle at the circumference. Now for one to really understand this theorem, Now, well, let me put it this way. There are many theorems that we are going to apply in dealing or solving circle, but each of the theorem has limitation. We have where each of the theorem has to be applied and where we are going to make use of them. So this is one of those theorems. And for one to apply this theorem, so that is the situation when we have any of the three diagrams which we are having here. So if the diagram given to me doesn't correspond with any of these diagrams, then this is not the right theorem to apply. But when we are given a question to solve, and what we observe is that what the question looks like any of the three diagrams here, then the right theorem we are going to apply is the one which states that what angle at the center is twice the angle at the circumference. Now, going to be able to use the theorem, you can see that when we observe the theorem, it is talking about two things. So the first thing it is talking about is what? Angle at the center. Why the other thing it is talking about is what? Angle at the circumference. So it will be necessary now to do how do we identify angle at the center in each case? Because diagram determines how to get the angle at the center. Now, when we have a pattern, a diagram that is like this, now what we call angle at the center is always this place. So that is one of the facts. So the mathematical fact as regarding the application of this theorem is that when we have this kind of diagram, this position here is what we call the angle at the center. While the angle we have above here is what we call the angle at the circumference. So that one is to be taken like that, it is a fact. So that is one case there, we can at the same time call it what is one. Now when we observe this other one, now the angle at the center in this situation is always after the last two lines I have here. So angle at the center in this case is here to here. So while the circumference is still to this area here. So don't make mistake of calling this place center. This is not the center. So the center, as far as this diagram is concerned, angle at the center, as far as it is concerned, is this place. It is this area we are going to treat as angle at the center. Because I have to make mention of this very well. So because these are the things that usually cause problem for the students. And lastly, this one, when we observe it, we see that it's more or less the same thing as the first one, only that instead of me to have my angle at the circumference directly above this angle at the center, we have it sidely here. So this one is still the same thing, more or less the same thing as this one. So this place still remains the center, while this place remains the circumference. So if this one is known, and we know when we apply any, when we make you since this thing is clear, let me state it that way. Since this thing is clear, then I think we should now go ahead to solving questions, applying our theorem. And remember, the theorem we have here, the first theorem, is going to be applicable in what situation whereby we are presented with any of the diagram above. So we are going to take our first example. Now, I have this diagram. Then I have 41 degree here, while here is Q. And I'm asked here to find the value of the metal angle. Now, when we look at this thing, we are going to see that it's corresponds to one of the three diagrams that I earlier drawn on the board. So which shows that the theorem which states that angle at the center is twice the angle at the circumference is going to be applicable. And what is the meaning of that theorem? What the theorem is saying is the angle we are going to have here double is the angle we are going to have here is double of any angle we have at the circumference. That is, two of this angle at the circumference will be equal to angle at the circumference. That is what the theorem is saying. So the theorem has to be stated by saying that angle the center is equal to 2 times whatever angle we have at circumference. And we can see at circumference we have 41 degrees. So it shows that Q here is going to be 2 times 41, which is going to be what? 82 degrees. And that is the simple solution to that first question. Now, secondly, what I have is this. And this place is out. Now, when we observe this question, we are also going to see that it's more or less the same thing as this thing. But the only difference between this and this is that a kind of turning occurred here. So, but since they are more or less the same thing, it shows that what the first theorem, that is the theorem which we are treating in this class, is going to be applicable. And that is the theorem which states that what angle the center is twice the angle at the circumference. So, what we now want to do is, what is the angle at the center? What is the angle at the circumference? So remember the theorem says that angle at the center. So that is the first thing we must be looking for. So what is my angle at the center in this question? Angle at the center is 106 degrees. So it means 106 degrees is equal to, it says that it is equal to twice. That is, it is 2 times whatever angle we have at the circumference. So you can see this time around at the circumference, the angle we have there is what? Is r. So this one has taught to simple equation. We just solve this equation so as to arrive at the given result. So we have this as what? 106 degrees is equal to 2r. And remember, to getting my r here means both sides has to be divided by what? The coefficient of r. So I will divide both sides by 2. Like this. So this one cancel this. You know 2 in 10 here is 5. Y 2 in 6 here is 3. Therefore, R is equal to what? 53 degrees. That is the second question. So the third one now, what I have is this. This place is called T. Why this place is called 126 degrees? If you can recall from the when I introduced this kind of diagram, so number one thing is to check this diagram. Does it belong to any of the 3 keys that the theorem is going to be applied on? So yes, we can see this one of those diagrams. Now, once you satisfy one of the requirements of the theorem, then the next thing is, what is the angle at the center? What is the angle at the circumference? Because the theorem talks majorly about what? The relationship that exists between what? Angle at the center as well as the angle at the circumference. And if you can recall, I said then that when we have this type of diagram where we call the center, that is where we refer, where we are going to refer as the center is going to be outside like this. So this is angle at the center. While here is going to be what? The circumference. So once the 2 is known, we automatically determine the value of t. So what we are just going to say now is we just take the theorem in order to what? To get the value of t. You know, by the theorem says that angle at the center. So the first thing we have to reckon with is whatever angle we have at the center. That whatever we have at the center is equal to 2 times whatever angle you have at the circumference. But we can see that the circumference value we have is 126. So that will be multiplied by 126 degrees. I know t in this time around will be the result we get when we carry out this multiplication. 2 times 6 here gives 12, with the remainder of 1. 2 times 2 4 plus that 1 5, and 2 times 1 and 2. So our result here is what? 252 degrees. That's question 3. In number 4. What I have is this. I have it like this. This one, like this, like this, like this. Now this place is called T. Why this place is called D? And this place is what? 135 degrees. So in this case we have to find both T and U. Now, what is important to us is we are dealing with circle geometry, and as far as circle geometry is concerned, we have a list of theorems. Now, the theorem that is going to be applicable to any diagram that is of this type is the one which states that what angle at the center is twice the angle at the circumference. So, since the theorem we want to talk about what relationship between center and circumference, then it is of importance we know what is the angle at the center and what is the angle at the circumference. And remember, I said it above that when we have this type of diagram, the center is this place, so while the circumference is this place. So to solve this now, simply we are going to say that whatever we have at the center, you can see it is t this time around. We say that the angle at the center is what? 2 times any value we have where at the circumference. So 2 times what? 135 degrees. So we can see t will be determined by what? Multiplying the result there. So 2 times 5 here is 10, 0 will be written with the remainder of 1. 2 times 26 plus that 1, 7, and 2 times 1 here is 2. So which means t is equal to 270 degrees. So I can put my value there. Now, I'm also asked to find u in this case. Now we can observe here that there is a particular relationship between this t and u. No, that is, for me to recap the t, I'm referring to t now as 270 instead of t again, because t now has what? Has a value. But there is a relationship between 270 and u. The relationship is that of angle at a point. You can see this is a line, we stop there. This is another line, we stop there. So we are going to make use of property of angle at the point. Now that one is determination of u is outside the concept of what? Circle geometry. All the circle geometry can do in solving this question is to get t. So once we've gotten t, there is nothing circle geometry can do here again. So for one to now determine the value of u, we make use of other aspects of geometry. And the aspect of geometry that will be of importance to us here is the one that talks about what? Angle between lines. So you can remember the one that talks about sum of angle at a point is equal to 360 degrees. That is what is needed here. Because it means addition of the angle here as well as the angle here will be equal to what? 360 degrees. And the reason there is this, as sum of angle at a point is equal to 360 degrees. Remember, this one has nothing to do with circle geometry. All circle geometry can offer us is to be able to distinguish between what? Angle at the center as well as the angle at the circumference. So this time around, we are just going to say that 270 degrees plus u is equal to 360 degrees. The reason for this, sum of angle at the point is equal to what? 360 degrees. To get my u here means I will just collect the light term, and we know u is going to be 360 degrees minus 270 degrees. So when the subtraction is carried out, the result we are going to get there is what? 90 degrees. So that is the fourth question there. So we have to solve as many questions as possible, because students usually consider this topic to be somewhat dreadful, and of which I consider it to be the most simplest topic out of all the topic in the SSCE level. So we go ahead with more questions because I prepared us with 10 questions for this class. Now, number 5. What I have here is this. With this and this, like this. This place is 119 degrees. So this is called X. This is y, and this is t. Now, for us to be able to solve this question, we have to consider the diagram in this question. And we are going to observe that this is combination of two diagrams. Now, the diagram will refer to as case 1 the other time, and the diagram will refer to as case 2. So those two diagrams were combined together in order to arrive at this question here. So for us to solve it, we are going to treat it separately. So we have to consider this diagram first. The one that looks like this, the one that is of this type. This is one case there. The other case is the one that looks like this, and like this. So how do we relate with this type of diagram then? That is how we have to relate with this thing. And remember, the diagram we talked about here has to do with relation between angle at the center as well as angle at the circumference. So when we have this type of diagram, where is going to be our center? If you remember, this is where we refer to as the center. Why this is the circumference? Now let us check the center and the circumference to see whether we are going to progress with this diagram or we are going to start with the diagram, the second diagram. Now when we observe this one, the diagram that resembles this one, this is this one like this, You can see its center is x, while its circumference is what? T. And at least a value must be given either at the center or at the circumference for one to be able to do or to relate with the diagram here. Since we have to find the value, it shows we can't begin solving this question with this form of diagram. So it shows that we are automatically going to start with the other diagram. And when we have this type of diagram, that is this type of diagram, where do we always call our center? So we can see in this situation, this is where we call the center. So center to this diagram here is going to be y. Its circumference is where we call 119 degrees. So we can now see that starting with this one is the good starting point for solving this question. So we are now going to talk about the content of the theorem which we want to apply. And the theorem states that angle at the center, that is y, is equal to 2 times the angle we see at the circumference. And at the circumference of this diagram, what value do we have there? 119. So that is 119. So y here becomes the result we get when the multiplication is carried out. We know 2 times 9 is 18. 8 is related there with the remainder of the 1. 2 times 1, 2 plus that 1, 3. And 2 times 1 here is 2. So y this time around gives the value of 238 degrees. To be necessary, we put the value there. That is 238 degrees. Now that we've gotten that, let's now make reference back. Okay, well, let us complete this type of diagram. Whenever we have this type of diagram, this is the center. Should this other angle be given here, we are going to make use of the property of what? Angle at sum of angle at a point is 360 degrees. Now to determine our x here. So it means that addition of the angle here and this angle here will be equal to what? 360 degrees. So it shows that what? 238 degrees plus x is equal to 360 degrees. Reason for this one, sum of angle at a point is equal to 360 degrees. So getting our x here means we're going to collect the light here. So we have it as x is equal to 360 degrees minus 238 degrees. So my x here will become, so I have 360 minus 238. 10 minus 8 here is 2. 5 minus 3 here is 2. So 122 degrees. So it shows our x here is 122 degrees. Now we can now fix the value here, 122 degrees. Now we can now make reference back to this diagram. Now remember, with this kind of diagram, this is the center. So we can see, when we consider this diagram like this, its center is now 122. But the circumference is, we are yet to get the circumference. So we are now going to relate the two by saying that what we have at the circumference is 2 times whatever we have at the circumference. That is 122 degrees is 2 times what we have at the circumference is what? T. So it's the same thing as writing 122 degrees is 2t. So getting that t here means both sides have to be divided by the coefficient of t. So over 2 over 2. So when this cancel this, 2 in 12 here is 6, while 2 in 2 here is 1. Therefore, t in this case is what? 61 degrees. So that is the question number 5 there. Now, the next is number 6. Number 6. So what I have in my number 6 is this. So this place is 134 degree. This is M. This is J, K, and L. Now, what we have to solve this time around is this. So when we observe it very well, we can still see that what it talks about the first diagram, the first case of the diagram that calls for the application of what angle at the center is twice the angle at the circumference. And what we have to do in this case is to identify that two major things that this theorem center on. And what are those two things? The theorem talks about the angle at the center as well as the angle at the circumference. Now, at the center, what value do we have there? It is K. At the circumference, what value do we have there? It is Z. So we can see that no solution yet. Then this shows that something else has to be done. So, because one of the two angles has to be known before I can apply the theorem. So the theorem is not going to be used at the moment. So we are going to think of how else can we relate with this thing so as to know at least angle at the center or the angle at the circumference. But when we observe this thing very well, we can see that the only value given this time around is 134 degrees, and it is placed somewhere here. So what we should think of now is what other property can we use, and the situation whereby application of the theorem is not going to work immediately. Then the next thing that must come to our mind is the property of what angle between lines. So I can say that this my 134 here is an angle on this line that we call straight line, and when we have a straight line that is divided into some parts, addition of all the angles on such a straight line is equal to 180 degrees. So which means this angle 124 and this angle M, they are all resting on this straight line. So this is it once again. This 134 and this, and you know, here to here is the measure of 134, here to here is the measure of M. So we can see that both angles M and 134, they are all resting on this straight line. So which shows that what sum of angle on a straight line property will have to be used here. And remember, sum of angle on a straight line is 180 degrees. So that means M plus 134 degrees is equal to 180 degrees. So then this time around is going to be 180 degrees minus 134 degrees. And then we give what value? 180, 134. 10 minus 4 here is 6. And 7 minus 3 here is what? 4. So that gives the value of what? 46 degrees. So we can see our M is 46. So 46 degrees can be positioned there. We can now see that now we've gotten angle at the circumference. So most angle, one of the two things that the theorem we are using talks about is given, then we can now make use of the theorem. So by making use of the theorem now calls for two things: angle at the center and angle at the circumference. So which means we have to start with angle at the center. That is, angle at the center, K is 2 times whatever is the value we have at the circumference. And we can see at the circumference we have the value of 46. So that is 2 multiplied by 46 degrees. So K this time around now gives the value of 92 degrees. So K is equal to 92 degrees. So it is also better I position my value here. K is 92 degrees. Now the rest is to get J and L. Remember I stated it above that the theorem we are using only talks about angle at the center and angle at the circumference, which you've already gotten. So circle geometry has nothing again to do with finding J and F. It is something else which we have learned in geometry that we are going to apply. And what we can apply here is, it is this type of triangular element that is of importance to us. Now when we consider this triangle here, so let me reproduce it here for clarity purpose. So here I have it as 92. This is J and this is L. And this diagram we have here, we can see that we have to know the nature of the triangle. What type of triangle is this? So that is what we need for us to know what the value of J and L is going to be. So we can see the type of triangle we have now is an isosceles triangle. Remember, Isosceles triangle is defined as a triangle that has what? Two of its sides equal. So we can see that line drawn from the center down to the circumference is called the radius. This is another center, this center, this circumference, this is another line. It's called radius. It shows that this side is equal to this side, and that is what we call what? An isosceles triangle. And the theorem told us that some opposite angles, base angles of isosceles triangle are equal. It shows that since this thing is an isosceles triangle, whatever value this one is the value this one is supposed to be. That is, if this is delta J, this one too is supposed to be called J. But since it is not called J for us, we are going to choose, it's a matter of must. We are going to choose a common word, a common letter for them. So it's either assume both to be J or assume both to be L. But for simplicity purpose, I will assume both angles happen to be J. Now that I've gotten that, so I will now say that what addition of all angles in this triangle is 180 degrees. That is by the theorem we state that what sum of angle in the triangle is 180 degrees. So that means J plus 92 degrees is equal to 180 degrees. So J plus J here gives 2J plus 92 degrees is equal to what? 180 degrees. It shows that 2J is what? 180 degrees minus 92 degrees. 2J here is going to give the value of what? 180 minus 92, that's going to be 88 degrees. 180 minus 92. So this is 10 minus 2, 8. So this is now 17 minus 9, that is 8, yes. That is 88 degrees. So getting J here means both sides will have to be divided by 2. And we can see that therefore J is equal to 44 degrees. What it now means is that this angle here is 44 degrees and this angle here is as well 44 degrees. So I think at this moment I would like and prefer to call it a day, or I would love to stop and pause here so that I still have series of assignments that I want to leave the students with. I want them to work over it so that in the next class